This section of work is all about sequences, and here we've got 5 different sequences. This first one, you can see the numbers are going up by 2 each time. The next number would be 15, 17, and so on. In the second sequence, the gap there is 1, the gap there is 2, the gap there is 3, the next gap would be 4, so the next one would be 18, then add 5, that would be 23. Here the numbers are just alternating between 8 and -8, so the next number would be 8, and then -8. Here we've got a sequence where the numbers are doubling every time. The next number would be 16, the next number would be 32. And this last one, Fibonacci sequence, 1 and 1 is 2, 1 and 2 is 3, 2 and 3 is 5, 3 and 5 is 8, so the next number would be 5 plus 8, 13, 8 plus 13, 21, and so on. So at A level we concentrate on this type where there's a number that's added on each time, there's a common difference, in this example it's 2, and we look at this type where there's a common ratio where it's multiplied every time, in this case again by 2. This type is called an arithmetic sequence. It looks like the word arithmetic, but it's pronounced arithmetic, and this is C1. This is a geometric sequence where the numbers are multiplied every time, and that's C2. Now at GCSE you would have done some work on finding the nth term of a sequence like this. Here's a reminder of that. These numbers are going up by 2 each time, so we can write un equals 2n plus 5. Now what does this mean? The n is the number of the term, so the first term, when n is 1, 2 times 1 is 2, plus 5 is 7. So we can say when n equals 1, u1 is 2 times 1 add 5, which is 7. N could be any number though, n could be 2. So when n equals 2, so instead of writing n there, I've written 2, so n equals 2, so it's 2 times 2, add 5, 4 and 5 is 9, and so on. u3 is 2 times 3, add 5, so that's 11. u4 is 2 times 4, add 5, that's 13, and so on. So where did I get this formula from? Well, the 2 is because it's going up by 2 each time. An increase of n, an increase of 1 in the n number increases the whole number here by 2, so it's 2 times n. 2 times 1 is 2, but the first term is 7. So 2 times 1 is 2, the first term is 7, so I've got to add 5. We can check it again. If n equals 2, 2 times 2 is 4, but that's 9, so I've got to add 5. So this is called the nth term of a sequence. So what is the 43rd term of this sequence? The 43rd term is where n equals 43. So u43 is 2 times 43, add 5, 86 plus 5 is 91. So having the formula, in this case 2n plus 1, allows us to get the numbers very quickly. If we said, here's this sequence, what's the millionth term in it? And you said, oh, well, I've got to keep adding 2, 15, 17, 19 and so on. It would take you several hours to get to the millionth term. But if we know that n is a million, I can just do 2 times a million, add 5. So straight away I can use that formula to work out what the millionth term is in this sequence. If I put n equals a million in there, 2 times a million, add 5, gives me the answer straight away. So this is a very powerful tool to have. Here's another sequence, 8, 11, 14, 17, 20, 23. And what we can say about this is that the first term, which is normally a, is 8. The number of terms in this sequence, which we call n, is 6. There's 6 terms, 1, 2, 3, 4, 5, 6. The difference is the number that it's going up by each time, so that's 3. S is the total of this sequence, so if you add up 8, 11, 14, 17, 20 and 23, we get 93. And the last term is 23. So just to recap, A is the first term, N is the number of terms, D is the difference, the number by which it's going up each time, S is the sum, the total of all the numbers, and L is the last term. Notice that the first term is A, the second term is A plus D, 8 plus 3 is 11, the third term is A plus D plus another D, 8 plus 3 plus 3, that's 14, and so on. So we can simplify this. That's A plus D, that's A plus 2D, that's A plus 3D, so U5 is A plus 4D, and U6 is A plus 5D. And it's worth paying careful attention to the fact that the number there, the sixth term, has got 5 differences added to it. The second term has got 1 difference added to it. So generally speaking, the nth term is A plus n minus 1D. The number that is here, 5, is 1 less than that. So a formula for the nth term of a sequence is A, the first term, and then it's n minus 1 lots of D to give you the nth term of the sequence. Now it's worth emphasising the difference between a sequence and a series. A series is formed by adding things up. Arithmetic series are formed by adding together the terms of an arithmetic sequence. Now previously we looked at a sequence being A plus D, A plus 2D, and so on. Now if there's n terms, the last term is A plus n minus 1D, because the number there in front of the D is 1 less than the actual term. That's the second term, that's the third term, and so on. So this is the sequence. So on the next slide we'll look at the series that we get. So here we've got the same sequence, but now I've written it as a series, so I put red plus signs between all the terms. And I've called this the sum of n terms. There's n terms in this sequence, and when we add them together we get the sum of the series, so there's n terms. Now what I'm going to do now is I'm going to write out the same formula, but I'm going to write it out backwards. I'm going to put so here I've written it out backwards. I've gone A there, A plus D there, I would have written A plus 2D there, and then I get the last term there and the term before that there. And now what I can do is I can add up those two equations. So I'm going to add the whole of that row to the whole of that row. So Sn plus Sn, that's 2Sn. Then I've got A, and I've got A plus n minus 1D. And then I've got A plus D plus A plus n minus 2D. Just check what I'm doing. I've added that expression to that expression, A plus D, that's there, then A plus n minus 2D, that's there. Let's carry on with this, plus dot 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 dot, and then the penultimate term is A plus n minus 2D, that's that bit, and I've got to add that to A plus D. And then the last terms are A plus n minus 1D plus A. Looks a bit of a mess, but very quickly we can simplify things, because if you look carefully at this, we've got A here, A plus A, that's 2A. So 2Sn is 2A plus n minus 1D. Now let's look at the next term, this bit here. We've got A, so that's 2A. There we are. So we've got A, that's 2A, then we've got n minus 2D plus another D. So that's n minus 2D plus 1D, that's n minus 1D. Oh, it's the same as that. Okay, looks good. N minus 1D plus dot 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 plus what have we got here? We've got A plus a, that's 2a. And then we've got n minus 2d plus d, that's what we had before. N minus 2 plus 1, that's n minus 1d. And you can probably see what's happening now. Let's look at the last term. A plus a, that's 2a plus n minus 1d. So every term, when we add them together, is the same. How many terms are there? Well, there's n. So 2sn is n lots of 2a plus n minus 1d, because every term is the same. So Sn is n over 2, 2a plus n minus 1d. And that's a pretty important formula. Now, another way of writing this formula is Sn is n over 2, 2a is a plus n minus 1d. But look carefully, the last term of the sequence is a plus n minus 1d. That's just that bit there. So the last term of the sequence, which if you remember a few minutes ago we called L, that's that bit there. So we can write Sn equals n over 2 a plus, and then instead of a plus n minus 1d, we can say L. L is the last term of the sequence. And that's another important formula. So we've got two formulas now for the sum to n terms of a series. So finally, here's an example. Find the sum of the first 20 terms of this series. What's a, the first term? So what's n? N is the number of terms, and that's 20 in this case. And what's d? Well, it's going up by 6 each time, so d equals 6. The formula for Sn, the sum is n over 2, 2a plus n minus 1d. So we can substitute in for this. S20 is 20 over 2, 2 times a, that's 16, n minus 1 is 19, 19 times d, that's 19 times 6. 20 divided by 2 is 10, 19 times 6 is 114, so it's 16 plus 114. 16 plus 114 is 130, so the sum is 1300.